we're just going to pick up where we left off. So we talked a little bit about virtualization and conceptually the models of the network that we want to be able to expose flexibly through the controller, and also multiple implementations that want to support those models. So Yun-Sun just went through a description of one of the implementations of virtualization that we have in the controller in the project, which is based on VTN, virtual tenant networking. And now I'm going to talk a little bit about another one of the implementations that we have, which is based on OpenDub. So OpenDub is, in summary, it's a virtualization platform that uses overlays to create multi-tenant virtual network in the data center. So these are logically isolated at layer 2 or layer 3, with layer 2 or layer 3 connectivity. And as with overlays, right, it runs on any underlying IP network. So it doesn't require any changes to the physical infrastructure. It completely is isolated to controlling edges, using software virtual switches rather. So this is also something that was a GA product before OpenDaylight. So it's based on a product from IBM called SDN-VE, or SDN for Virtual Environments. And SDN-VE in turn was based on technology that was called Dub in our research labs. So what we've done with OpenDaylight is taken pretty much most, and I'll explain the differences of the SDN-VE product and brought it into OpenDaylight as an open source contribution. And as with any sort of migration of product into an open source project, there is some architectural change needed and a bunch of work that's happening, because we never intended to open source it before OpenDaylight came along, but we thought it as a great opportunity when OpenDaylight came along. So there's some evolution, and I'll explain what the architectural evolution is. Because I think somebody's question, maybe yourself, about how much are we using in OpenDaylight, what are we leveraging from the controller? I think maybe you asked, right?
Yeah.
I'll explain that also. So that's changing as we evolve the architecture. So what does OpenDub feature? It's got, we intended to bring all of the pieces. In other words, it's not meant to be kind of something to use for experiments or in a toy environment. We really want it to be ready for prime time deployment, real deployments. So as a result, it's got all of the features that we have in the commercial product, including HA and clustering and scale out, gateways to get in and out of the virtual networks, etc. So there's a full control plane implementation that includes address dissemination and management, policy management, the ability to handle VMs moving around in the network. We've got a management interface that provides a programmatic way to set up virtual networks and tear them down. I'll explain more about that. The data plane implementation is based on Open vSwitch. So we're actually using stock OVS, and then we're writing an agent to work with it, and I'll show a little bit about how that works. So we use VXLAN encapsulation on the wire, for those of you who know what that is. And we also include the gateway piece. It's a software gateway that's used to connect non-virtualized or legacy networks into virtual networks in the data center. So I don't know, does everyone know how multi-tenant overlays work? Okay, so maybe it's worth just reviewing quickly. So basically what you want to do, the abstraction that you're typically providing at a high level, is this notion of each tenant in the data center gets their own virtual network abstraction. It doesn't have to be a single switch, but essentially their own sort of private network. Right? So in this picture we have two tenants, tenant 1 and 2, that have their own virtual network. I've drawn it as a single switch here, but you can represent it different ways. And basically you just connect your VMs to that network in a variety of ways. So there's an SDN controller in this architecture that basically uses overlays to virtualize the physical network infrastructure. So the way that works is that the SDN controller is managing virtual switches that reside in hypervisors at the edge. So your virtual machines are running on these hosts. There's a vSwitch in here. And the SDN controller is creating these overlays and managing the virtual networks by managing these vSwitches. So basically these overlays are created across the network for each tenant, and they are terminated on the vSwitches at each host. So basically the advantage of this approach is that you deploy your network once, architected however you want. If you like big flat layer 2, or you'd like to carve up into lots of subnets, whatever the best practice is, you have your IP fabric, and then your virtual networks are created just by manipulating vSwitches and managing them at the edge. Right, so it's implemented purely on end hosts with software and encapsulation, and I'll explain how the encapsulation works. One of the things we talked about this morning with some of the scaling limitations of traditional VLANs, the idea of overlays, of course, is to get past those, right? So we could create many, many more virtual networks than we can VLANs. We also, don't expose all of the end hosts, to the physical infrastructure. They only know about actual physical hosts as opposed to virtual machines. So that reduces the pressure on things like MAC tables and physical switches and all of that, right? So those are some of the advantages of overlays. So in Dove, how we implemented this solution, this basic architecture, is as I'm showing here. So, with Dove, you can create multiple virtual networks. These virtual networks can span hosts across the data center, with VMs residing, all on different hosts. These parts in orange are all the pieces or all the components of the Dove architecture. So I'll go through them one by one. You have the management console. This is sort of the user interface, the configuration interface for creating virtual networks, tearing them down, setting up policies, all of that. So it exposes a REST API that then you can tie into an OpenStack, a Cloud Stack, other application provisioning systems in the data center. So this you can think of as the management interface for Dove. The connectivity server runs as a cluster. This is essentially the control plane for Dove. So the connectivity server handles things like address dissemination, discovery of VMs and their location, handling of policy dissemination. All of those kinds of things are managed in the control plane. And then we have a Dove switch that resides in each host. And as I said, in OpenDove, the Dove switch is based on OVS. So we use a stock OVS, one of the most recent versions that supports encapsulation using VXLAN, and we add a user agent to it that helps us integrate it with the rest of Dove. And in addition, we have a gateway. So the gateway basically allows you to send traffic from a virtual network out into the rest of your data center network, for example, on a VLAN. So we could map a VNet, a virtual network ID, to a VLAN ID and push traffic out onto the virtual network and vice versa. Or it could send it out on the external IP network by setting up NAT rules and IP forwarding, static IP forwarding in the gateway. So it's a fairly simple thing, but it's very important and useful in the data center to get in and out of the virtual network. So this means that you could run a service on one of these VMs that's exposed and accessible through the gateway by hosts that aren't actually part of a virtual network, right? By using that and forwarding here. Any questions on the high-level architecture?
Does the agent run user space?
You mean on the data plane side?
Well, to make an OpenDove vSwitch, you said you start with a regular vSwitch and then you add an agent. And I'm asking, is the agent something that runs in the user space?
Yeah. I'll show you a picture of that in detail.
And the OpenDove gateway, is that a software?
Yeah. Today it's a software gateway. But I think as we're getting hardware support in switches for encapsulation, we can start to incorporate hardware gateways also.
And is that something you're releasing as part of this history, or is it a separate product?
So we have a product called SDMVE that has exactly the same architecture. The real difference is that we support multiple hypervisor types. Here we're just focusing on OVS and open hypervisors. But the rest of the components, as far as the control plane, management plane, are largely the same. I say largely because we've rewritten the management plane, and we will be rewriting parts of the control plane to work in a more integrated fashion in the controller. I'll show you that.
And the hypervisors work with Zen and KVM right now? Then?
Yeah, because it's OVS based, so it can support Zen and KVM. Any other questions? Okay. So let me say a little bit about the operation of Dove, in various aspects. This is kind of at a high level, but I think it helps explain, how Dove works. And this probably applies to a lot of other overlay virtualization techniques also. So let's talk a little bit about address discovery. So if we take this example, you have a bunch of hosts with VMs on them. Once a VM comes online and activates, the Dove vSwitch will detect that VM's IP and MAC address. And what it does is it pushes that information out to the connectivity server. So the connectivity server is running in this cluster in the data center. And the Dove vSwitch is updating the DCS when a VM comes up or goes away. So it learns about addresses and their location. Someone else mentioned about gratuitous ARPing and things like that. So we use that kind of stuff also when a VM first comes online. And then the DCS basically share the address mapping right away. So when it's pushed to one of the DCS nodes, the rest of the nodes in the cluster will learn about it very quickly. So it gets shared across the DCSs right away so that they all know about where the endpoint is. Now when a VM wants to communicate with a VM on some other host, the vSwitch, if it doesn't know where it resides, will request address resolution from the DCS. The DCS will tell it where it is, and then it can start, it knows which vSwitch it resides on and which tunnel therefore to send it on, and it also caches that information locally at the vSwitch. And it gets invalidated when the VM moves and the DCS learns about a new location, for example. I won't get into all of the, there's a lot of nitty-gritty behind this, and if you have questions later, we can talk offline about all of that. I probably can't answer all of them, but I can get people who can. So a little bit about the encapsulation. This is also fairly simple. So from the VM's point of view, right, it knows nothing about the virtual network. It knows nothing about encapsulation. It's just sending regular packets on the network. So it sends a packet to a source, talking to a destination in the data center. We'll just send a packet with an IP address on it and a MAC address that it knows about to the VM. What happens at the vSwitch is that we encapsulate it in an outer envelope, which includes the physical network's Ethernet address and IP address for the vSwitch on the other end of the tunnel, and we also have this dub header that defines which tenant this packet belongs to. So I'm showing the dub header format down here. This essentially is just standard VXLAN framing though. So we're just using standard VXLAN packet framing. We use the VNID or the VNI field as the identifier to be able to isolate packets that belong to different virtual networks. So that packet is sent across the IP cloud. It shows up at the destination vSwitch, using the outer address. The vSwitch strips off, the encapsulation header, and then it delivers the packet to the destination VM. Right. So this is very standard overlay operation. I just wanted to make the point that we use, VXLAN. So VXLAN, if you look at the IETF draft, it doesn't really mention a control plane. It talks about things like IP multicast as a way to discover endpoints that you don't know about. We don't use any of that, but we do use the packet framing that they define, right? The standard VXLAN framing. A little bit more about the operation. So in this case, in this example, you have two VMs that are trying to reach each other, talk to each other, that are on different hosts and different vSwitches. VM 1 and 3 are part of the same virtual network or belong to the same tenant. VM 2 and 4 likewise are part of a different virtual network. So the VM is attached to the vSwitch, via its VNIC, and it wants to send VM 1 wants to send data to VM 3, and that packet enters the vSwitch. The vSwitch figures out that VM 3 is on vSwitch 2 using the address resolution that we talked about. The vSwitch basically encapsulates the packet for delivery over the physical network. You use the overlay ID to basically isolate the traffic logically. And the physical networks know about the vSwitch locations and their addresses, but not about the VM addresses, right? So this is another way that you are scaling this. The way this approach scales is that these endpoint addresses, the VMs, aren't exposed on the physical network. It only knows about actual end hosts, right, or physical hosts. So the physical network delivers the packet encapsulated to the vSwitch. It strips off the encapsulation header, as we said, and delivers the packet to VM3. So this is just another way of looking at what I was showing before in the encapsulation. We also have the notion of policies in Dove. So policies basically manage how different virtual networks are allowed to exchange traffic. So we have this notion of a default off policy. So unless you explicitly allow it, traffic is not allowed to go between virtual networks. So you enable it explicitly in Dove. And the policy can be customized for different virtual networks in different ways. And as I mentioned, we have a gateway that operates in two modes. We've got a VLAN gateway mode that basically puts virtual network traffic onto a VLAN segment, or it can run in this external gateway mode where we actually can talk to nodes on an external network. It supports NAT or pass-through modes if you want to run services, for example, inside a virtual network that need to be accessible outside. So in OpenDove, we're going to support both of those modes in the gateway. Now, a little bit, I talked at the beginning about different network models. So I just wanted to give an example of what the native Dove network model is. And this is sort of separate from the API that we exposed, but internal to Dove, And in the product, we actually expose this API directly, but in OpenDub, we're trying to simplify it a little bit. So Dub virtual networks are basically just a very small group of abstractions. You have something called a domain, which roughly corresponds to a tenant. You typically think of a domain as belonging to a tenant. You have something called a virtual network, and you can have multiple of those inside a domain, as this picture shows. You have a subnet because you have to assign addressing somehow. So we have the notion of a subnet, mask gateway that you assign to a virtual network. We have policies that I talked about that govern, whether or not traffic can pass between virtual networks. And then we have a gateway that actually is required to get traffic across domains because, as I said, the idea is that a domain roughly maps to a tenant, and if you really want inter-tenant traffic, you need to explicitly enable that through a gateway. But within a domain, you can have multiple virtual networks. They have their own subnets. You can exchange traffic based on the policy setting, that allows traffic to be exchanged. And you can have, overlapping subnets in different domains, but in the same domain, they have to be distinct. But a different tenant can be using the same subnet, as another one, right? So that's all supported. Any questions on the model? Yeah.
Just one question about the policy. Is it just on-off binary thing? You can change or not, or is it more like a firewall kind of thing? Like
So
how stateful is this thing?
Yeah, so today it's basically allow deny kind of stuff, and we're adding support for kind of more actual. It's not. I wouldn't say it's stateful though. It's just more fine-grained, I guess, on-off than just on-off.
Would it make sense to say, instead of a policy, say, well, when I want to go from here to there, go through this service, which may be just, a firewall?
Yeah, so we're working on that also. The notion of, middle boxes or waypoints that you want to pass through is something that we're looking at also. So I think that's something we'd like to do with the community as well. So we will be bringing that. But today, the OpenDub stuff that we're working on is kind of just we're trying to just get it working in OpenDaylight, and then we'll sort of start enhancing it.
Right, but in that, with that concept, wouldn't those policies reside outside of Dove in a perfect world? Wouldn't that be either an application or part of the controller?
They would be specified maybe outside of Dove,
Okay.
and then they could be implemented by, right. So, yeah, you probably want a generic framework for policy and even for expressing middle boxes that, is implemented depending on what virtual network technology is used. So, if you're using VTN, it wouldn't work the same way as if you're using Dove, but you'd like the API or the framework to express the policy to be the same, absolutely. Okay, any other questions on the model? Okay. So what are we bringing to OpenDub to start with in OpenDaylight? We have the management console, and I'll show architecturally where it sits. It actually sits in the controller as a bundle and takes advantage of some of the controller services. It provides a set of REST APIs for programming virtual networks. The REST APIs are based largely on OpenStack Neutron APIs. They're APIs that everyone uses and understands. So we wanted to use something that's common in the industry. We have the Dub connectivity server with the clustering support. That's also part of the contribution. As I said, the Dub vSwitch that we have is based on OVS plus a user space agent. I'll show a picture of that, and then the gateway piece. The gateway is consists of a loadable kernel module, for the data path part of it, and then it's got a user space agent to configure it. So as you can see, Dub has a little bit of additional complexity beyond some of the other projects that are just building services that sit in the controller, right? There's other moving parts to Dub that sit outside the controller, like a data plane component or like a gateway component that necessarily can't sit in the controller unless you want the controller in your data path, which I think nobody thinks is a good idea, right? So some of the distribution packaging issues we're still working through, like how can we distribute the required pieces. Some of them are licensed differently, like the loadable kernel module is going to be GPL code, and then the rest of it is all, EPL code, as OpenDaylight is EPL licensed. We're still sorting through that, but the idea is to make it easy to download a package, get the third-party dependencies, and get up and running as quickly as we can. So this is kind of the architecture that we're starting with. As I showed before, the DCS and the DMC run separately, and so what we've done initially, all of the code, by the way, all of Dub is written in C and C++, so it's not Java-based, so it's not ready for turning into OSGI bundles right away and putting into the controller. So this is a process that we're going through over some period of time. Right, so what we started with is taking the DMC, which is the management piece, we call it ODMC for Open Dev Management Console, have rewritten it as a Java OSGI bundle. It exports REST APIs northbound, and southbound talks to the control plane piece, the ODCS. This is the Open Dev connectivity service that runs outside of the controller today and uses its own clustering protocol, right? So the DMC basically gets configuration requests from the user, and it uses OpenDaylight's sort of synchronization and the distributed hash table that I mentioned to basically synchronize that state and that configuration data across the cluster of controllers. But the clustering that happens at the DCS is its own clustering protocol today. And then the DCS talks to the data plane element, which is the user space agent that sits on top of OBS, using a client-server protocol that we're actually in the process of publishing as an IETF draft also. We'd like to get comment on it. I don't know if people who work in IETF may know this NVO3 working group, which is about network virtualization. They're actually looking for different implementations of control plane protocols, because most of the stuff like VXLAN and NVGRE, those drafts don't talk about control plane. So we're going to be publishing the client-server protocol there. The code is there today. You can see how the client-server protocol works. And then there's also a REST protocol, a REST interface to talk to the Dev gateway piece. So this is how the current architecture looks today.
Does the ODCS have a data plane and a control plane component?
No, it's just control plane stuff, right? So all the data plane stuff is either down here on the host with OBS, or in the gateway. So it's not, it doesn't, maybe you're thinking of like OpenFlow, where you have some data packets that actually go up to the controller. We don't have that here.
No, even like NSX has a service node, and the service node has a control plane. So I was trying to figure out, I assume in that environment, your OD gateway is closest.
It's the closest to that service node, yeah, exactly. So just a little bit more detail on the vSwitch. So we're using 1.11, the latest version that just got released of OBS. It has all the support that we need in kernel. We didn't, earlier on when we were working on Dev and OBS, we had to make changes to the kernel modules, but now as OBS has evolved, we're able to just use vanilla OBS. And we couple it with an agent that sits on the host and talks to both the DMC and the DCS. I'll explain the interaction with the DMC because I already went through the interaction with the DCS. And it uses OpenFlow rules locally to program the OBS. So I think you were asking earlier about OpenFlow to program or put forwarding down into the OBS. That's exactly what we do here. So essentially what we do is we get commands from the DCS, and then those are pushed via OpenFlow down into OBS from the user space agent. Now, I'll get to that in a second. So the kinds of things that the vSwitch has to talk to the management console for are things like initial registration and bootstrap. There's a health check that runs between the vSwitch and the DMC so that the DMC can learn, and the vSwitch also can learn about failures. It has to be told who its DCS is, right? So the DMC's job is to tell the vSwitch, here's a cluster leader for the DCS, so contact it and register with it. This is who you should talk to for address resolution. All the virtual network creation. So virtual network creation requests come into the DMC, and those get pushed out to both the DCS and also get updated in the vSwitches in some cases. It's actually a little bit platform dependent, but for OBS this will happen. And there's also statistics. I think you were asking about statistics earlier. So we have this framework for actually collecting statistics from the vSwitch. So you can specify what statistics you want using these key value pairs, and then the vSwitch will push back those statistics, or the agent will push back statistics to the DMC, who can then expose them to the user. We're still in the process of defining exactly what those stats will be, but your standard stuff with traffic and bandwidth loss and that kind of stuff. Where we'd like to take the architecture is kind of more in this direction. So if you think about it, the controller in our initial version really has the management piece in it, as opposed to the control plane piece, right? What really should be the case is that the control plane piece, which is the DCS, should be in the controller and a management plane piece should be kind of an application that lives on top of the controller. Right, so that's what we're trying to evolve to going forward. It requires a big rewrite of the DCS, so that's why it's taking some time. But eventually, and in addition to that, as I said, the agent that runs on the host pushes OpenFlow locally down into OBS, but there's no reason that you couldn't use OpenFlow directly from the DCS, right? If you take that functionality and pull it into the DCS, then you could just run OpenFlow directly down to the OBS. So that's something else we're considering. But then you still need some configuration capability, so that REST API to the host agent will still be there. So this is kind of where we're headed over. It'll take us some time to get there as we evolve the code, but the idea is to pull the DCS and leverage the clustering, for example, that's built into OpenDaylight as the way that we can support, clustered, ODCS nodes as well, right? So we'll be taking more advantage of the services that the controller provides as we evolve the architecture. Any questions on this or comment? Okay. Now let's step back a bit and sort of kind of figure out, we talked about two different virtualization solutions in OpenDove. This is our favorite picture now that Ed gave us.
Most of the credit goes to Phil and Chris. I just did the last round that everybody saw.
So this is the virtualization edition that Ed presented earlier today. And as you can see, we've talked about a few of the components here, right, that I've highlighted in red, so related to VPN and Dove, and I'll talk about what this OpenStack service is as well. So how do these things, work together? Basically what we have in OpenDaylight is two different ways of creating virtual networks. And if you recall back to when we started this talk, this session, we talked about the importance of having multiple implementation choices. So that's exactly what we have on sort of the bottom half of this, right? We've got a way to implement virtual networks using overlays if you just have an IP fabric. And you've also got the ability to use OpenFlow if you've got an OpenFlow enabled fabric, through the VTN manager. Now, what about the model part? So what we're aiming for, going forward, and I think we're going to get there pretty soon, is that we want to be able to support multiple models. So today, in the OpenDove case, we export an API or a network model that looks like the Neutron network model, right? So it's got networks and subnets and ports and all of those parameters that you attach to them. So that's the network model that Dove exposes today. Internally, it's got that other object model that I showed with domains and network, but externally to users, they interact with Dove the same way they would interact with OpenStack Neutron, right? So that's one API that we're going to support. Another API that we'd like to support or make available is the VTN API. So if you like this notion of being able to create networks by setting up vBridges, vRouters, tunnels, bypass, all those elements that Yoon-san described, if that's the preferred way of setting up your virtual networks. A lot of us don't like the Neutron model, right? For whatever reason, there's all kinds of extensions being proposed all the time for it. So, VPN is another option. But the idea is that we want to be able to support both on both, right? So in other words, if you have the VTN API, we'd like to be able to implement it underneath to the extent that we can support all those abstractions with Dove, or with OpenFlow. And similarly for the Neutron API, right? So the Neutron API should be able to map onto overlay networks with Dove or OpenFlow networks with VPN. So here we have a case of multiple network models or APIs, and then multiple virtualization implementations. So as we add virtualization capability to the controller, whether it's through Lisp or through standard VLANs, this will evolve, but we want to have this sort of guiding principle that, we want the set of APIs to be universally available to the implementations and vice versa. That's not always going to be straightforward, right? Because some of the primitives, for example, in VTN may not map directly to things that we can implement in overlay and vice versa, right? But to the extent possible, we want to do that.
I guess I don't understand why the Neutron APIs would drive because I guess if I understand, I get that VPN API is something that this VPN manager exposes, and then there's a different API that might make sense for your DMC. But you would develop some plugin in OpenStack, right, that would talk to whatever common API you have. So I guess I don't understand the Neutron API piece in terms of why it's at the same level as VPN.
Yeah, so I'm just trying to show here that, there's two models or APIs for programming virtual networks that we're shooting for. One model is exactly the neutron model. It doesn't have to be, but that's one model that we've chosen. And then another model is the VTN model. So as far as OpenStack integration, I'll get to that next, but that's a different question. So there's no OpenStack in this picture. It just so happens that the API for virtual networks, or one of the APIs, looks like the neutron API.
Right.
So hopefully that's clear to people, right? So this is regardless of what orchestration platform is sitting above. Could be OpenStack, could be anything. But it's programming virtual networks using Neutron
But
or VTN.
doesn't OpenDaylight have a particular, I guess, grammar for its REST API that everybody follows? In other words, like OpenStack in general has a whole hierarchy of how you do REST and versioning, etc. Right? And it's all kind of a Python library that So then I guess each of the projects like Neutron inherit that. I guess they can change it, but fundamentally that's kind of the legacy. So I guess I'm just asking on you. I mean, do we have that at OpenDaylight in terms of overall framework for REST? And then like when you want to do VPN, you do your flavor on it and DMC and every other, or is it kind of roll your own? Because that's kind of what this implies, is that there's like a whole bunch of different.
No, so there is a framework for all the REST APIs in OpenDaylight. What I'm showing here, so don't think of this as the only APIs that will be there for, we could expose additional APIs, but we want to have some standard that people, can program to. And, the Neutron REST API is just one model, and I'll show you in the next picture or two, how we're sort of positioning that as sort of the de facto way to interface to OpenStack. But there could be other APIs as well. And yes, there is sort of a standard way to create REST interfaces in OpenDaylight that all the projects are using, that live in the control.
Because implied by that common is that there's common objects that are within the controller that all these REST APIs now reference or modify.
Yeah,
so,
this part is a work in progress in OpenDaylight though, right? So, it's sort of a mix of, we started out with kind of the Wild West in terms of every project has got its APIs, and it's, now we're starting to add some governance and some common mechanisms in the controller that projects can use to expose their APIs in a consistent way. So that's happening. This picture really should be taken as just, examples of virtualization specific APIs. There's a lot of other things the controller does, right? But this is just a subset of the APIs that we're trying to expose. So OpenStack, so at a high level, I hope it's clear to folks that, if we think about OpenStack, essentially Neutron is just providing an API layer, and underneath it you need some backend to implement those APIs, right? So OpenDaylight, as we discussed earlier, I think when Kyle was on the panel, he talked a little bit about making OpenDaylight a de facto implementation for Neutron APIs in OpenStack. And this isn't, I don't mean to imply that we're not interested in other orchestration platforms. It's just that there's enough folks in the community who are interested in OpenStack that that's the first thing we're looking at. But CloudStack and VCAC and other things are all fair game, right? So you have all of your projects in OpenStack that are providing compute and image and storage, and then you have Neutron, which is providing the network APIs. So essentially what you've got is, the OpenStack Networking Manager, which is Neutron. It's got its core APIs, it's got API extensions, and it's got a plugin, right, a plugin model. And you were asking about the relation of SDN to the Neutron model. So here, Neutron is just an API which exposes, constructs like networks and subnets and ports, etc., and their parameters. And essentially, those APIs need to be implemented somehow, and they're implemented by calling out to OpenDaylight, which is going to expose, as I'll show in the next picture, a service that basically collects those requests, and then they can be implemented in actually multiple ways in the controller, as we've seen in this talk. Right, so I'll say a little bit more about what that is. But the hope is that this layer, this plugin, can be as simple as possible. Right? If we can create a service that has exactly the Neutron APIs, this essentially becomes a pass-through to OpenDaylight. Right? It's just getting a request from the user and passing it to OpenDaylight, and OpenDaylight handles all the complexity of actually implementing that thing. There's very little that has to be done in the plugin that way.
Okay, so alternatively, you have to have a bunch of different plugins depending upon the manager
Yes.
the technology, okay, all right.
Right, so,
But there's already a lot of plugins. In other words, I mean, that's how that whole community works. There's, one for Nexus, there's one for, the regular ODS, that ships. So I think, the framework is designed around multi-vendors providing plugins for their networking. So,
yeah, but I'll explain how we're trying to simplify that picture, right? So if you, let me go to the next picture. So, you have two integration options. Let's just focus on the left side of the picture for a moment. So in the OpenStack case, as you said, there's a framework, they've got a modular L2 driver now, right, that supports multiple ways of implementing L2 virtual networks in OpenStack. So you can create different types of networks. So you could, the idea is that you can simultaneously manage, a VXLAN overlay-based network and, an NVGRE-based overlay network and maybe a VLAN-based overlay network. So you've got a bunch of different options, and each of those shows up as a different type in the ML2 plugin. And so that type corresponds to a mechanism. The mechanism driver will actually, call out to an implementation of that network type, right? What we're trying to do here with OpenDaylight is, manage that complexity and the heterogeneity of the network in the SDN control, in the SDN layer. So what we're planning to propose, and this is still in the oven as I'm saying here, so it's still being baked. This is kind of fresh off the presses here. Is have an ODP plugin, an OpenDaylight project plugin for ML2, where it's a new type altogether. So it's not a VXLAN type, it's not an OVS type, it's not a Linux vBridge type, it's its own type, it's an OpenDaylight type driver. And that guy is just going to call out, or essentially pass through, as I said, to a Neutron API service that we're building in the controller. So this Neutron API service gets all the Neutron requests that come out of OpenStack, and it creates objects out of those, puts them somewhere where services that are going to implement those calls, like create network, create port, list subnets, all of that stuff, those are implemented underneath by somebody. This service's job is just to do the interfacing, right? So it gets requests, package them into an object, puts them somewhere, and then people can, when I say people, these services or implementations can subscribe to this service, get notified when there's a new request, pick it up, and then go and implement it in the network. So rather than having a separate Neutron API for every single, virtual network mechanism that we have in OpenDaylight, we're trying to factor out that common service and basically provide it as the API. So this would be the de facto way that OpenDaylight interfaces to OpenStack. And this service is going to have to evolve just as the Neutron API evolves. The plugin will stay simple. Clearly the plugin probably will be distributed with OpenStack going forward. It's too late for Havana, but we're aiming for that for Icehouse. And then you have things like Dove and VTN, OVSDB, or OVS rather, and Lisp, that can use this API service to do all of the, marshalling of requests, handling all the, error passing back to OpenStack, all of that stuff that the Neutron API service provides, and it can be notified whenever there's a new call and go do its thing. That's the idea. And then in addition, right, we have another model, right, as I said, the VTN model, which will also be available, that API. And the hope is that, these services will also provide a mapping of VTN, down to what their object model is. So the Lisp object model is different than the Dove object model, which is different than the VTN object model. But there's no reason why they couldn't actually map VTN constructs into their own native object model and be able to support that API as well. So if you, for example, have an application that you've written to work with VTN, the idea is that if you, like that model and you want to keep that model, you can continue to use it, but you can implement it even if you don't have an OpenFlow network, right? Or you want to use it on a Lisp-based environment. So hopefully that's clear, what the strategy is for OpenStack integration for network virtualization, and the notion of trying to support different models for the network, with the different implementations we have. So I'm going to stop there. I still see a lot of confused faces, so let's see if there's questions.
So the status of both of these projects, their ideas, and they're going to be post the December release?
So the OpenDove project and the VTN project are on board for the December release, so that stuff will be there. We are working to have the OpenStack ML2 plugin for OpenDaylight available for the December release, but it won't be in the OpenStack distro at that point because we're too late for that now.
Okay.
Ed, do you want to comment?
Yeah, I mean, the plan basically is to make that plugin available at OpenDaylight in December, and then it'll be popping up in Icehouse when Icehouse comes out in March.
Okay, but does that mean the API service will be ready?
Oh, yes.
Yeah, so
Okay.
the API service is in flight now, right? So
Okay.
that's being developed.
Yeah, in
So-
fact, the last I heard was the conversation about where to put it
Yeah.
on IRC today.
Yeah, so those debates aside, I mean, we will have this API service and we'll have consumers of it also, right? So we'll likely have at least, you know, the OVS-based virtual network implementation and the Dove-based virtual network implementation, and hopefully the VPN also. So these lines that I'm drawing so casually on PowerPoint, these don't all exist. The only lines that exist today between VTN is to the VPN manager, right? So we'd like to be able to, our aspiration is to support all these models, you know, with all the different services we have. The only line that exists here, these lines don't exist at all. So this is being sort of finalized in development. And then, you know, I think we'll very quickly be able to, you know, make these lines real to Dove and to OVS. And then these two would follow. Is that clear?
Yeah, okay, so I have one more question. Are you considering extending the VTN coordinator API? This is kind of one of the northbound APIs, right?
Could be, yeah.
So is whatever it is now what it's going to be, or are there other categories of applications that might require that API to be extended?
I'll ask you something to answer that.
So you asking the right side?
Yeah, on the right side.
So today we already published all the API for our application, but if some partner or project request more API, we can certainly discuss and expand.
Roughly how many applications interoperate with the VPN coordinator right now?
Oh, no official project in the data community, but as a partner with the NEC, so we have some application.
Right. It's a good thing.
So people who use the NEC product today, for example, would like to have the VPN API made, right, on OpenDaylight. So they could use an OpenDaylight platform, but continue to use the same API that they do. Any other questions on this?
Any idea yet how that will be sort of packaged when it comes out? I mean, will it come out as a sort of packaged up and list on all those things, or will it be
Yes, we have talked about packaging, not packaging, but sort of what's in the edition, right? So we talked about release editions. I don't know, maybe you missed Ed's talk earlier, but so there's a couple of variations of this picture. So there's a bunch of modules that represent different kinds of functionality. So the idea is that, you know, if you put everything in there, it's going to be too hard for anyone to grok or much less use. So we've tried to identify specific classes of functionality and labeled them as, you know, release vehicles. So we have an edition that focuses on virtualization. So it's, right, that was what Ed was describing, and then another one that focuses on things that are important to service provider environments, etc. So the packaging would be this way. I mean, I don't want to say packaging because we still haven't decided what is the mechanism. Do we give you everything with config files for each of these different flavors, or do we let you, you know, just have you download some specific subset of the modules and then it just works directly? I think that's still, as far as I know, not decided.
There are opinions, but
Yeah, there are. So weigh in with yours. Any other questions? Okay, thanks very much, everybody, for sitting through this long session. We're coming back after the break.